The sun is gone. Not in a billion years, not in some distant future. Right now, this very second, our star has simply vanished. But here is the strangest part. You do not know yet. Nobody on Earth knows. And for the next 8 minutes and 20 seconds, nobody will. Because the sun is 150 million kilometers away, and light, the fastest thing in the universe, needs exactly 8 minutes and 20 seconds to cross that distance. Which means right now, at this very moment, photons that left the sun's surface over 8 minutes ago are still traveling toward us, still carrying warmth, still carrying light from a star that no longer exists. For 8 more minutes, the world looks perfectly, beautifully normal. Sunlight pours through windows. It paints golden rectangles on wooden floors. It warms the faces of children running through parks. Somewhere, a farmer wipes sweat from his forehead under a blazing sky. Ocean waves catch the light and turn it into a million sparkling mirrors. A sundial casts its shadow, faithfully telling the time. Rows of solar panels drink in energy from a star that is already gone. And in every forest, every field, every blade of grass on Earth, the quiet miracle of photosynthesis continues. Green leaves absorb sunlight and split water molecules and weave carbon dioxide into sugar. Starlight transformed into life. The fundamental chemistry that feeds almost every living thing on this planet. And not a single leaf knows that the light it is using right now is the last light it will ever receive. Then the 8 minutes are up. The last photons arrive, and in an instant, not gradually like a sunset, but all at once, like someone flipped a switch, darkness falls across the entire planet. The sky goes from blue to black in seconds. Every shadow vanishes because there is no light left to cast them. Stars appear overhead in the middle of what should be a Tuesday afternoon. The Milky Way, usually invisible from any city on Earth, blazes across the sky in full glory. Billions of stars, suddenly revealed as if the universe had been hiding behind a curtain of blue and we never knew. Car headlights switch on automatically. Street lights flicker to life across every city on the planet. Emergency sirens begin wailing. Traffic slows to a crawl as every driver on every road suddenly cannot see. Airports scramble to emergency protocols. Satellite dishes spin, scanning the sky for a signal, for an explanation, for anything. There is nothing to find. But the darkness is not the most dangerous thing that just happened. Something far worse occurred in the same instant. Something no human can feel. Earth just lost its gravitational anchor. The sun contains 99.86% of all the mass in our solar system. Its gravity is what holds every planet in orbit. And because gravity propagates at the speed of light, the moment those last photons arrived was also the moment Earth felt the sun's gravity disappear. Our planet, traveling at nearly 30 kilometers per second in its orbit, is no longer curving. It flies off in a straight line, like a stone released from a sling, heading into the void of interstellar space. And not just Earth, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune. Every planet breaks free at the same instant, each flying off on its own tangent line in a different direction. The solar system, Our cosmic neighborhood for 4.5 billion years comes apart like a broken clock, pieces scattering into the dark. The moon stays with us. It is bound to Earth's gravity, not the sun's. But without sunlight to reflect, the moon becomes invisible, a dark ghost, revealed only when it passes in front of a star and blocks its light. And there is one more loss that nobody notices yet. The sun did not just provide light and gravity. It produced a constant stream of charged particles called the solar wind, which inflated a vast protective bubble around our entire solar system called the heliosphere. That bubble shielded us from the worst of interstellar cosmic radiation. Now it is gone. Earth's own magnetic field is still there, still deflecting most cosmic rays, but the outer shield, the big one, has collapsed. We are exposed. Earth is now a rogue planet, homeless, starless, hurtling through the galaxy at 30 kilometers per second with no destination. On the International Space Station, an astronaut floats to the cupola observation window and looks down. The view is unlike anything any human has ever seen from orbit. Earth is almost entirely dark. The familiar blue marble is gone, replaced by a black sphere speckled with tiny clusters of electric light. Cities glow like dying campfires scattered across a vast dark plain. And where the sun should be, there is nothing, just stars. More stars than this astronaut has ever seen, even from space. The Milky Way stretches across the void in impossible detail, no longer washed out by solar glare. It is the most beautiful and the most terrifying sight in the history of human spaceflight. And the temperature has begun to drop. In the first hour, you would barely notice, maybe a degree or two colder than expected. That is because Earth is not just warmed by the sun in real time. Our atmosphere and our oceans are enormous heat batteries. The oceans alone have been absorbing solar energy for billions of years. They hold a staggering amount of thermal energy, and they do not give it up quickly. Where warm ocean water meets the rapidly cooling air, thick fog forms. Massive fog banks roll off coastlines and pour into city streets. The ocean is fighting back, releasing its stored heat into the atmosphere, trying to maintain a balance that no longer has any input on the other side. By the end of the first day, the average temperature has dropped maybe 5 to 10 degrees below normal. It is cold, unpleasantly cold, especially for places that were warm, but not yet deadly, not yet catastrophic. Furnaces click on in houses, people put on extra layers. Grocery stores are crowded as people stock up, not yet sure what is happening, only knowing that the sun did not come back. But Earth's energy budget is now permanently broken. Every second, thermal radiation streams outward into space, and absolutely nothing is coming in to replace it. The planet is bleeding heat into the void, and the bleeding will not stop. Within the first week, the average global surface temperature drops to around -18 degrees Celsius, 0 degrees Fahrenheit, in 1 week. Snow falls on the Sahara Desert, frost coats orchids in the Amazon. Tropical rainforests, ecosystems that have not experienced freezing temperatures in millions of years, are suddenly encased in ice. Broad palm leaves, evolved for eternal warmth, crack and shatter. The great canopy of the Amazon, the most biodiverse place on Earth, begins collapsing under the weight of ice it was never built to carry. Rivers freeze solid. Waterfalls stop mid-cascade and turn into enormous ice sculptures. Coastlines crystallize as the ocean surface begins to freeze from the shores inward. Each day, the ice extends further, sealing the water below under a thickening white lid. But here is an irony that borders on poetic. The ice that kills the surface actually protects what lies beneath. Ice is a remarkable insulator. As the ocean surface freezes, the ice layer traps the heat in the water below, dramatically slowing further freezing. This is why lakes freeze from the top down, not the bottom up. And this same physics, scaled up to a planetary ocean, means that the deep sea will remain liquid not for months or years, but for hundreds of thousands of years. The ocean will outlast everything on the surface by an almost absurd margin. Large trees survive longer than anything else on land. An ancient oak or a giant sequoia has enough stored sugar in its trunk to metabolize for weeks, even decades, without photosynthesis. Their metabolism is slow. They burn through reserves in the dark, but they are running on fumes, and the fumes will eventually run out. Infrastructure begins to fail. Hydroelectric dams choke as reservoirs freeze over. Power transmission lines sag under the weight of ice until towers buckle and cables snap. The electrical grid, designed for seasonal variation, not permanent Arctic conditions, comes apart piece by piece. But humanity does not go quietly. Nuclear power plants become the new centers of civilization. They generate heat and electricity independent of the sun. Geothermal regions, places like Iceland and Yellowstone, where heat from Earth's interior reaches the surface naturally, become the most valuable locations on the planet. Communities dig underground. They build sealed habitats with artificial LED lighting and hydroponic farms, growing food without a single ray of sunlight. Air is recycled, water is recycled, every molecule counts. But 8 billion people cannot survive on nuclear and geothermal power, not even close. Within weeks, the majority of the human population begins to perish. Those who survive cluster around the few remaining energy sources, building a new kind of civilization underground, smaller, fragile, completely dependent on machines. Meanwhile, beneath the frozen ocean, something remarkable continues. 4 kilometers below the surface, on the ocean floor, hydrothermal vents pump superheated, mineral-rich water from deep inside the Earth. Around these vents, entire ecosystems thrive. Tube worms, extremophile bacteria, deep-sea shrimp. They feed not on sunlight, but on chemical energy through a process called chemosynthesis. These organisms have never needed the sun. They do not know it is gone, and they will not care. As weeks turn to months, the surface becomes unrecognizable. Cities stand frozen and abandoned, skyscrapers encased in ice, streets buried, vehicles frozen in place, encrusted with frost, so thick they look like sculptures. The Great Barrier Reef is visible through clear frozen seawater, an underwater museum locked in ice. Then, around month 8, something extraordinary happens. The temperature drops below -78.5 degrees Celsius, and carbon dioxide, which makes up a tiny fraction of our atmosphere, begins to freeze, not into liquid, directly into solid. Dry ice falls from the sky like snow, frozen carbon dioxide, sparkling white, settling onto the ice already covering the ground. 2 distinct layers now, water ice on the bottom, dry ice on top, a landscape that has never existed on this planet before. This is the first stage of atmospheric collapse. By month 6, ocean ice is meters thick. Pressure ridges form where ice plates collide, making Earth's ocean surface look more like Jupiter's moon Europa than the world we knew. The sky is visibly thinning. Stars grow sharper each night as less and less gas remains overhead to scatter their light. You can actually see the atmosphere disappearing. Around month 17, a year and a half after the sun vanished, the temperature drops below -183 degrees Celsius. Oxygen begins to liquefy. Pale blue liquid oxygen drips from the thinning sky and pools on the frozen ground. The air we breathe, falling as rain. Shortly after, at -196 degrees, nitrogen follows. 78% of our atmosphere condensing into blue liquid, raining down and freezing on contact. The atmosphere is literally falling out of the sky. Think about that for a moment. The air you are breathing right now, the invisible ocean of gas that surrounds you, that fills your lungs, that carries sound and weather and the smell of rain. It is not permanent. It is only gas because it is warm enough to remain gas. Take away enough heat and air becomes liquid. Take away more and it becomes ice. The same air, just colder. Within roughly 2 years of the sun's disappearance, the entire atmosphere has frozen solid onto the surface. Several meters of nitrogen and oxygen ice now cover everything. There is no sky anymore, just space, visible directly from the ground. Stars are sharp and unblinking because there is nothing left to make them twinkle. No wind, no weather, no sound, because sound requires air, and there is no air left. The atmosphere stabilizes at about 43 Kelvin, -230 degrees Celsius. Earth now looks like Pluto, frozen, airless, dead. Underground, the last communities survive on nuclear power, but reactors have a finite fuel supply. Decades pass. Instrument panels show declining readings. Fuel rods approach empty. Warning lights shift from amber to red. Hydroponic grow lights flicker as power fades. Corridors go dim. The last generator winds down. The final generation of humans lives in twilight. They were born underground. They have never seen the sun. They know it only from stories and from the archives stored on servers that are slowly losing power. They have done everything right. They recycled every breath. They rationed every calorie. But physics does not negotiate. When the fuel is gone, it is gone. On the frozen surface, a radio antenna, the last piece of technology still transmitting, broadcasts a final automated signal into the void. Its red indicator light blinks, flickers, goes dark. Earth's last word to the universe, spoken to no one. From orbit, Earth is now completely dark. No city lights, no electromagnetic emissions, no sign that anything intelligent ever lived here. The planet is indistinguishable from a billion other dead rocks drifting through the galaxy. But in the deep ocean, behind kilometers of ice, the hydrothermal vents still glow. Earth's internal heat is not solar. It comes from 2 sources: residual heat from the planet's violent formation 4.5 billion years ago, and the continuous radioactive decay of uranium, thorium, and potassium in the mantle and core. Together, these produce roughly 40 to 47 terawatts of power. This furnace has been burning since the Earth was born, and it will continue for billions of years. 1,000 years after the Sun vanished, the vent ecosystems thrive. Multiple active chimneys pump minerals into the deep ocean. Dense colonies of tube worms and bacteria carpet the rocks.
A hidden world, alive in permanent darkness. If you could somehow visit this place, you would never know anything had changed. The vents look exactly as they did when the sun was shining, because down here, the sun never mattered. 10,000 years, 100,000, the deep ocean remains liquid, insulated under kilometers of ice. Life persists, evolves even. In the absence of any surface influence, the deep ocean ecosystem continues its slow biological dance. New species of bacteria adapt to shifting mineral compositions. Tubeworm colonies expand and contract around vent fields. Life, in its most fundamental form, simply carries on. But over millions of years, the radioactive fuel slowly diminishes. Not dramatically. The half-life of uranium-238 is 4.5 billion years. The decline is glacial, but it is real. The mantle cools fractionally, century by century. Convection currents slow by imperceptible amounts. Vent output drops. Some vents go cold, their chimneys standing as dark, dead towers on the ocean floor. The ecosystem contracts. Life retreats to fewer and fewer warm spots. After tens of millions of years, perhaps 100 million, most vents are gone. After several 100 million years, the last vent weakens to a trickle. The last bacteria, clinging to fading warmth, reach the end of their line. 4 billion years of unbroken biology. Finished. Earth drifts through interstellar space. Occasionally, it passes near a distant star. A red dwarf casts faint reddish light across the frozen surface. Not enough to warm anything, just enough to illuminate the ice. Then the planet moves on, back into darkness, one rogue world among billions. Now here is the reassuring truth. The sun cannot actually disappear. The laws of physics do not allow it. Conservation of energy, conservation of mass.
2 nonillion kilograms of hydrogen and helium cannot simply cease to exist. What the sun will actually do is evolve. In roughly 5 billion years, it will exhaust the hydrogen in its core. It will swell into a red giant, enormous and red, large enough to swallow Mercury and Venus and possibly reach Earth's orbit. Then it will shed its outer layers in a beautiful glowing planetary nebula, leaving behind a tiny, dense white dwarf that will cool slowly over trillions of years. A quiet retirement for an ordinary star. But here is what makes our thought experiment scientifically fascinating rather than just terrifying. Rogue planets are real. Billions of them wander the Milky Way. Recent studies suggest there may be more rogue planets drifting between stars than there are stars in the entire galaxy. Orphaned worlds ejected from their home systems by gravitational chaos, wandering the darkness forever. And some of them might be alive. Jupiter's moon Europa has a cracked icy surface. Beneath that ice lies a global ocean of liquid water, kept warm not by the sun, which barely reaches Jupiter, but by tidal heating. Jupiter's immense gravity flexes Europa's interior, generating friction and heat, enough to maintain liquid water. enough possibly to power hydrothermal vents on Europa's ocean floor, the same kind of vents that support life in Earth's deep ocean. Saturn's moon, Enceladus, is even more tantalizing. Geysers of water ice erupt from its south pole, spraying material from an underground ocean directly into space. In one of the most remarkable moments in the history of space exploration, the Cassini spacecraft actually flew through these plumes. It tasted the ocean of another world without ever landing. And what it found was extraordinary. Silica nanoparticles, organic molecules, molecular hydrogen, all pointing to hot water interacting with rock at temperatures above 90 degrees Celsius on the ocean floor. That is not just warm water, that is active hydrothermal chemistry, the exact same conditions that support life at Earth's deep-sea vents. If life exists on Europa or Enceladus, worlds that receive almost no solar energy, it proves something revolutionary. Life does not need a star. Life needs three things: energy, liquid water, and the right chemistry. A star is one way to get energy, but radioactive decay works too. Tidal heating works too. Chemical reactions deep in a planet's interior work too. Some of those billions of rogue planets drifting through our galaxy might be larger than Earth, with thick ice shells insulating deep internal oceans, heated by their own radioactive cores for billions of years. Microbial ecosystems thriving in absolute darkness far from the nearest star. A galaxy full of hidden life we cannot see and may never detect. Life in the universe might be far, far more common than we have ever imagined, and far less dependent on stars than we have always assumed. The sun will rise tomorrow morning, and the morning after that, and every morning for roughly 5 billion more years. Our star is middle-aged, stable, and utterly reliable. But our thought experiment reveals something we almost never stop to think about. We live on a razor's edge. One ordinary star at exactly the right distance makes the difference between this thriving blue world and a frozen dead rock no different from Pluto. The warmth on your face on a summer afternoon, the green of every leaf performing its quiet photosynthetic miracle, the blue of an ocean held at precisely the right temperature for liquid water, a wheat field turning stellar energy into the bread on your table, a sunrise painting the sky in gold and orange over the curved horizon of our planet. All of it, every bit of it, traces back to nuclear fusion reactions happening 150 million kilometers away, inside an unremarkable yellow dwarf star that has been doing its job quietly and faithfully for 4.5 billion years. We are solar-powered creatures on a solar-powered world. Everything we are, everything we have built, everything we have ever loved exists because one ordinary star showed up to work every single day since before life began. The food on your plate, solar energy converted by plants into calories. The oxygen in your lungs, a waste product of photosynthesis powered by the sun. The water cycle that brings rain to farms and rivers to oceans, driven by solar heating. The wind that turns turbines and pushes sailboats, created by uneven solar heating of Earth's surface. Even fossil fuels, coal and oil and gas, are just ancient sunlight stored in the compressed bodies of organisms that ate the sun's energy millions of years ago. Remove the sun and you remove everything. Not slowly, not gradually. Within 2 years, the air itself is frozen on the ground. Perhaps the most valuable thing this thought experiment teaches us is not fear, it is gratitude. Not for something rare or exotic, but for the most ordinary, most reliable, most overlooked thing in our sky, the sun. If this made you see the next sunrise a little differently, hit subscribe. We explore the most mind-bending questions about our universe every single week. And next time, we are asking a question just as terrifying. What if the moon suddenly doubled in size? See you there.